Okay, I guess we are again live and let's see. Advent of Code day 6 and let's try this out. This time the question is really simple, I guess. And the question states if we have a string and we just need to check for the four recent characters and if that's there, right? And all of them are distinct, return that index, last four characters, right? All of them are different. The first, the first one to get this, and that's the answer. Seems like an easy problem to me, to be honest. Uh, but um, uh, I guess having four characters is not something we are gonna have. Like if I just see the input, it's big line. It's a big line, I guess, right? So I'm just trying this out. First of all, let me commit my 5.cc. So added 5 fifth messy day with Haskell. Okay, okay. So now let's try it out. hmm 6.hs and 6 dot uh, prod, and that's a big line. That's a big line. I guess it's kind of 1000 characters or something, right? It's 5000 characters. So, because I'm from a competitive programming background, I know this is going to be for the four characters fine, but when k increases, um, this is not going to help, right? If k increases to 100, so I have to do this in order of n only, right? Somehow, if it was C++, then it was really easy. Um, let's try to do this in Haskell. And currently, like, I only have thought of recursion right now, right? So, this time the question is really, really simple. Um, it's like get line and print. Um, get line solve dot print, and I just need to solve it, right? So solve is something that takes a string and returns me an integer. Solve is str equal to undefined, right? Okay, now this makes sense. But basically, I guess because this is going to be just algorithmic thing, nothing else than that. What I'm gonna do is I'm gonna have solve um, get idx kind of function that again takes a string and returns an int, but it also takes an integer, right? It also takes an integer that is the window size. That is the k. For us, the window size is k. Okay, so currently the algorithm is like nk algorithm, and I want to do this in order of an algorithm. So let me try it out. strk is undefined again, and just return this get idx 4, right? Just get idx 4, nothing else than that. Yep, and I can actually just have, right, now this works. Um, it's just get idx 4. So my point here is how I can do this is by maintaining a map, right? By maintaining a map. Mhm. So initially there would be low and there would be high. And I would call this str prime actually because I want to access the elements of str all the time. All the time I want to access the elements of str. So str is list array, and I want to access the elements. So it's like 1 to length of str prime and str prime. So this is something um, we are gonna use. Right. So it takes bounds. So list array just converts this string to uh, array of characters, and it takes bounds. So our array starts with index 1 and ends with index n. And I can have n2. N is length of str prime, and I can actually just go for even n minus 1 kind of stuff, 0 to n minus 1, because we are familiar with that, right? Hmm. So now we have str, and now we can index everything, like access the element in constant time, right? So how it goes like, so mhm, at every point of time, right? At every point of time, uh, we'd have a high, a low, and an index, right? A high, a low, and an index. That is how it is going to be, right? And we need to work with that, right? So, okay, uh, how increment stack works like is we increment the stack, then we decrement the stack, and that's really, really interesting way. I would really love if someone would solve this without recursion, uh, and uses some sort of fold or scans. The first part can be, but I don't think the second part can be, right? Or can we use some sort of fold? Because in C++, this is like really, really easy. Really easy. I'd code this in C++ for starting just to get how it looks like. Okay, so auto str equal to std, um, just read std string. Okay, and solve string view str and llk. Okay, and how I do this in C++ is I start with low and high. Low should be 0, high should also be 0. I take n, that is the size of str. I take unordered set of char, and you know, even unordered set of char is not necessary. I can just have array of char, array of int 26. Okay, frequency, that is all initialized to 0. Okay, high is not equal to n plus plus high. So frequency auto const c is equal to stri and is high. Okay, and frequency of c minus a is going to be just increased. Okay, and while frequency of c minus a, okay, and str high str c minus a is going to be greater than 1. Okay, what I can do is uh, frequency of c str low minus a, I can just decrease that frequency, right? And it's like a sliding window, and the array is doing the part of increasing and decreasing, and because if we add an element, only that element frequency changes and we don't need to worry about the other elements, right? So this is how it goes like. Okay, and now if high minus low plus 1 is just k, I can just return high. Okay, and actually for our purposes it's high plus 1, and if at last we didn't find any of such thing, okay, we return uh, minus 1. So for us this is the case. Start cout solve str4, right? Okay, so this is how we do this in C++, right? And let me try it out. Dot slash, do I have C? Okay, copy code forces C dot 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 slash C6 win slash 6, and I can just have C dot 6 dot prod, that is 1142 for our case, and I can just try it out right here. 1142, let's see if it works. And yeah, we got it, we got 1 star. Part 2 you can correctly. Okay, and now it's asking for 14 distinct character only, right? It's just asking for 14 distinct character. That is how I just did this question, right? 6.cc, and it's just asking for 14 different characters. So it is just utilizing the fact that we need, this is an square algorithm, like nk algorithm, and k is 14 is fine, even not a big deal to be honest. um, I don't know if that would have been worked, but 2803, that doesn't seem to be the answer, but yeah, that works. That just works. So this is how we do this in C++. A simple C++ thingy, right? Okay, but and I didn't go for examples, like I just went for, you know, uh, the loop, the prod one directly, because this thing I'm so confident in. But okay, I need something else right now. So let me start. Let me start. We need to do this in Haskell, and I just open C++ example for the motivation, because I don't know how to do it this right. So, mm, okay, frequency. So I don't know if we have some sort of you know uh, do we have unordered set or something hash? Actually, we don't have hash set in Haskell standard library, I guess, right? So we don't have that, but we have a set. I guess we have a set import data data dot hash set. Okay, we have a hash set for us. Okay, so let me just try it out. Okay, so I would start with a hash set, and let's see what does data dot hash set guarantee us. Data dot hash set. What does it guarantee us? So basic operation is check if map or try or something. Performance, documentation. Yep. Empty, combine, union, null, size, member, insert. Insert is login. Okay, it's login thing. Delete is login, right? Subset is login, right? So insert is login, delete is login, and subset is login. This is how this looks like, right? So first thing is delete um, from stack. Okay, so delete. Okay, so delete is a function. Okay, um, it goes from low to high. Okay, and hmm, so how it looks like? It looks like so delete. Okay, so low, high, and set. Okay, so this actually gives us a pair of low and set after deletion, right? This just gives a pair of low and set after the deletion, and yeah, this seems to work. This seems to work. Uh-huh. Let's try it out. So, um, I have low to high. Okay, I have low to high, all these elements, and I just need to drop. Okay, I just need to drop uh, until we have so drop. We have this drop while algorithm, right? And drop while. Okay, um, str high. Actually, member dot high and hash set. Okay, yeah, but it should work with the current state, right? It should work with the current state, not the original state. Okay. So the problem is, okay, let me tell what I want to do. Delete low, high, and str, st. Okay, okay, undefined. Okay, how I want it to be, delete the elements of delete the elements low till uh, current st uh, str high is not a member, is a member. right? This is something I want it to be, but I don't know if I can achieve this. Is there some elegant way of writing it? I can just go for recursion. That's right. But drop while m drop while m and control.monad.loops. I can just go for this. Okay. Okay. So mbool. Um, Execute a function repeatedly till the condition is satisfied. Collect the result in a list. Mhm. Until m is something that we want, right? Until n is something I want, and okay. I guess drop while m is something that is what I want to have. Drop while m. Drop while m is something that we want to have, but um, I don't know. Monadic loops. Monadic loops. Haskell. Okay. Hmm. Hmm. Control.monad. Control.monad.state. Hmm. Okay. Hmm. Drop while m and hmm. Hmm. I really don't know how to do this in a great way in Haskell, right? Okay. Like I can just go for the bad way. Like if st high.
On data hash map I want, I guess. Okay, and okay, st the restrict. Okay, is greater than 1, then it's like low plus 1. It's delete of low plus 1, high, and A2 maybe A. Update. Okay. Um, hmm. Low frequency. Hash map dot insert. Right. Hmm. What is the key? So str low. What is the value? It is low frequency -1 and st. Otherwise, it's just low comma st. Right. Where low frequency is equal to high frequency. This. What's the problem with this? Right. This is really hard, yeah. This is really hard. Okay. Hmm. 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 Okay. Huh. Low frequencies. Delete takes int hash map of char and any hash map. What's the problem? Okay, so now delete is like this. Okay. Hmm. So new st is something we delete the low character, right? So one of the we decrease the one of the low frequency. So hash map dot insert. Okay, what is the key? What's the value? What's the set? Delete st is something it takes integer. It takes hash map dot hash map of char int and returns a pair of int hash map dot hash map of char and int. Okay, now it makes sense. Okay, so we have delete st. Mm, insert st is such that it takes an int uh, high and st is equal to high element is and high fric and it's just like hash map dot insert high element and high fric plus 1. Okay, that's insert at st. Okay, what's next? The last thing is just mhm, mm, we need to go from a point where there is low. St is we need to insert, then we need to delete, okay. It should be look like first we need to insert, right? First I need to insert, so is insert st ist st equal to delete st low high inserted st, right? It's just like, and once we got deleted st, um we use this output new low high and did st uh, is k, then it's I plus 1. Otherwise, it's just proc new low I plus 1 deleted st proc 0 and minus 1. Alright, it takes int, takes int, takes hash map dot hash map of char int, and it returns me an int. Okay, it takes int. Hmm, hash map dot insert. Okay, yeah, we should pass st hash map dot high ele. Now what's the problem here? New log. Okay, this seems to be the thing. Let me try it out. Wow, key not found. Wow. Line number 54 is problematic, right? Insert st. So I can find with default. And we take 0, we take key, that is ile, we take st. Out of range. Out of range. What's this problem? Uh, uh-huh. Wow. What's the problem with that? Hmm. Get index 4. Let's try it out now. What's the problem? Are we using range or something? Oh, oh, oh. You're just okay. 4096 to 4095. Index 4096 is being accessed. Why it is happening? I'm really unsure of it. Ah. Hmm. This kind of question I really hate, right? This kind of question I really hate. In Haskell, not in general. Okay. In Haskell, this kind of question like really sucks for me. hmm Okay. So I'm going to do this. Let's just check what is happening right here, right? We need to check somehow what is exactly happening, 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 right? So let's try this out. Try this out. Six dot example. I need to somehow from list and like 102 and 1. Actually, like first let me make it hash set only. Okay. At this point, I can just trace, right? Trace show st f1 f1. Okay. Where is f right here? F right here is like this. This is f right here. Really, this doesn't seems to provide us a inserted st. It's just f1 only. 04094. Oh fuck. Oh fuck, 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 fuck. That is now how should we write? 00, this is how it should be called, right? And 1142, was it the answer? Was 1142 the answer? 1142 was the answer. Okay, yep. We did solve it. We did solve it. So let me remove trace and solve prime. Uh, Print solve str 2803 and I goes. So we did solve it, and this is the thing. After solving, we got this one. However, I hate it, to be honest. Uh, bad Haskell, but get C++. I really hate it how I did solve it. For the obvious reason that it's like a full recursion, and I didn't want to go on the recursion path. I think it could be more declarative, right? So let's go and check out other solution. Okay, I don't know how much time we have been there. Ah, we can check out some other solutions, right? I can just go and um, go for AOC 2022 all GitHub and check people solution, right? Okay, not people's normal solution, people's Haskell solution. Okay, so it's 2 days ago, it's 11 hours ago, so let's check it out. Day 6, pretty easy one, right? People are like pretty easy one. Uh, what he did, handle 14. Hmm, I don't know. Let me go for this one. Source solutions. Ah, it's not day 6. Mm, mm, mm. 2 hours ago, day 6. Tuning.hs. Uh, okay, I don't know how people do it, but I'd some like what's the best way of doing it? That's still I'm not sure. Mm, type safety. Okay, this guy didn't do right. I guess this guy didn't do it. Yep, this guy didn't do it right now. Oh, this guy just took things to extreme. Oh wow. Hmm. Okay, I don't know how people are doing it. But yeah, that's what it. That was it. C++ and Haskell solution we have. Let's see if we can do good in day 7, and can I get to a good point with day 6, because day 6 was really crap for me. Um, how I am looking at day 6 was, it was a kind of recursion, but we were passing the state throughout the recursion, right? We were passing the state, and this state passing is kind of a state monad. That is what I feel, and we should be able to do this
um, state monad thing um, with folds, drop while kind of stuff. That is what I feel. So, yeah, let's see what this is, how it is going to be. Because integers have state, and I don't know, no idea for that, right? So, yep. Okay, yeah, that was all. It was a nice stream. Thank you, everyone. Bye bye. Have a nice day. Yeah, people have commented I'm online. Uh-huh. Thanks, Sishan. But I don't think he's currently online. But yeah,